Astronomers have discovered 3 young planets orbiting a teenage sun in a sea of stars. Floating in a stream of young stars, astronomers have observed a trio of neighboring planets that are quite similar to our Earth. These young planets are orbiting a much younger version of our Sun. The research team found the young hot worlds using observations from NASA's Transiting Exoplanet Survey satellite. The planets are orbiting a star that has been named TOI 451. The system is located in a newly discovered Pisces Eridanus stellar stream, which is less than 3% the age of our solar system. It stretches across 1/3 of the sky. These so-called rivers of stars form when the gravity of our galaxy, the Milky Way, rips apart clusters of stars and dwarf galaxies, forming an elongated grouping that continues to disperse into a stream over time. Astronomers believe that this system is quite intriguing. It is only 120 million years old and just 400 light years away, which allows detailed observations of this young planetary system. And because there are 3 planets between 2 and 4 times the size of our Earth, they make especially promising targets for testing theories about how planetary atmospheres evolve. The Pisces Eridanus, named for the constellations with the highest number of stars, stretches across 14 constellations in total, measuring about 1,300 light years long. According to the assessments that have been done by astronomers, this system is only 120 million years old, 8 times younger than previous estimates. Its young age makes it particularly exciting for studying planetary and stellar formation along with evolution. The system star TOI 451, also known as CD 381467, is located in the constellation Eridanus, which is approximately 400 light years away. It has 95% of our Sun's mass, but it is only 12% smaller, slightly colder, and emits 35% less energy. The TOI 451 rotates every 5.1 days, 5 times faster than the Sun. The Sun of this newly discovered planetary system is like a teenager in comparison to our own Sun, Solis. That means that its planets are still changing and evolving. All 3 planets are very hot and quite inhospitable to life as we know it on Earth. They orbit their star 3 times closer than Mercury ever gets to do around our Sun. Temperature estimates range from approximately 2,200 degrees Fahrenheit for the innermost planet to approximately 840 degrees Fahrenheit for the outermost planet. The closest planet orbits a star roughly every 2 days, while the farthest one circles the star every 16 days. They range in size between that of Earth and Neptune from our solar system. While there are over 4,000 known planets outside of our solar system, most of these planets are quite much older and much farther away from Earth than the newly discovered system of planets. According to the research team, only 7 other young systems with multiple transiting planets have ever been discovered by astronomers. This planetary trio gives astronomers the rare opportunity to study a group of growing planets. Researchers plan to continue studying the planets using NASA's Hubble Space Telescope and its planned successor, the James Webb Space Telescope. They will use these instruments to examine how systems like our own solar system evolve over time. Through these studies, these planets will be viewed in the context of others. They will be able to put together the picture of how planets form and develop, therefore getting a better idea of planetary formation and development. These 3 young planets were discovered in test images taken between October and December 2018. When astronomers went on to do follow-up studies of TOI 451 and its planets, They included observations made in 2019 and 2020 using NASA's Spitzer Space Telescope, which has since been retired, as well as many ground-based facilities. Archival infrared data from NASA's Near-Earth Object Wide Field Infrared Survey Explorer satellite collected between 2009 and 2011 under its previous moniker WISE suggests that the system retains a cool disk of dust and rocky debris. Other observations indicate that TOI 451 likely has two distant stellar companions circling each other far beyond the planets. This system checks a lot of important areas and critical criteria based on what astronomers believe makes it ideal for further astronomical studies and research. This 120 million years old system is only 400 light years away, and therefore astronomers see this system as being perfect for theory testing on how planetary atmospheres evolve and develop over time. This planetary system is a part of the Pisces-Eridanus stream, which, according to astronomers, may have been formed when the gravity of our Milky Way galaxy tears apart star clusters or dwarf galaxies. The respective individual stars then move out along the cluster's original orbit and forms an elongated group that gradually disperses and forms a stream. The Pisces-Eridanus stream contains the greatest concentrations of stars. It stretches across 14 constellations, and of course, according to astronomers, it is 1,300 light years long. The age of this Pisces-Eridanus stream, however, was previously determined to be much older than what we think at this time. In 2019, there was a research that revealed that younger stars spin faster than their older counterparts, and that they also tend to have more prominent star spots. Their star spots are darker and cooler, and they have cooler regions like sunspots. As these spots rotate in and out of our view, they can produce slight variations in a star's brightness, and this is the level of luminosity that TESS can measure. TESS's measurements revealed overwhelming evidence of star spots and rapid rotation among the stream's stars, based on the data that was returned. The researchers therefore went on to determine that the Eridanus Pisces stream was only 120 million years old. It had a similar age to that of the famous Pleiades cluster, and 8 times much younger than previous estimates. The mass youth and proximity of the Pisces-Eridanus stream make it an exciting fundamental laboratory for research work on stellar and planetary formation and evolution. TESS has provided all-sky coverage, measurements, and other fascinating functions that could support search and further work on planets orbiting members of this stream. And it has provided this data so quickly, as soon as the stream was identified. Many persons believe that the TESS data will continue to allow them to push the limits of what they already know about exoplanets and their systems for years to come in the future. Based on the work that TESS does, it observes new worlds by looking for transits, which are the slight regular dimmings that occur when a planet passes in front of its star from our perspective. Transits from all 3 planets were evident in the data that was collected by TESS. The team obtained measurements from Spitzer and supported the TESS findings with this, and this would have allowed them to rule out the possibility of alternative explanations. Additional follow-up work and observations came from Las Cumbres Observatory, a global telescope network that is located in Goleta in California, as well as the Perth Exoplanet Survey Telescope that is located in Australia. Thanks for watching. Have a wonderful day. Goodbye.